32.5% solution of magnesium sulfate at 120 degrees Fahrenheit is cooled without appreciable evaporation to 70 degrees Fahrenheit in a batch water-cooled crystallizer. How much heat must be removed from the solution per ton of crystals? So let's draw the given. So this is your crystallizer. This is your feed. And then this is your vapor. And this is your L and C. So with this, you're given the XF, and then you're given the XL, given the XC. So what else is given in here? 32.5 solution. So here, this is 0.325. At what temperature? 120. So temperature of the feed is 120 Fahrenheit. What else do we know? Without appreciable evaporation to 70 degrees Fahrenheit. So that means here, TL, which is the same as TC, is 70 degrees Fahrenheit. So what is required? How much heat must be removed per ton of crystal? So Q per ton of crystal. So how do we solve this? So let's go to the solutions. First, the basis is, it says per ton of crystal. So I can say that my basis would be 1 ton of crystal, which is 2,000 pounds. So overall material balance, F is equal to V plus L plus C. And it so happened that since there's no appreciable evaporation, the V would be 0. So I can say that F, the 1 ton is the crystal. So F is equal to L plus 2,000 pounds of crystal. So let's just call this equation number 1. Okay, what else do we know of? So let's go to the component balances. So for the component balance, F XF is equal to L XL plus C XC. So do we know what XL is? So we don't know what XL is, but what type of system is this? Magnesium sulfate. Okay. So guys, for magnesium sulfate, can you go to 27.3? The magnesium sulfate system, or 27.4? I'll check because it should give us, like, we're lacking data. For this one, we need to solve for the XL, the solubility at 70 degrees Celsius. And then we need the XC. For the XC at 70 degrees Celsius, you should also solve at 70 degrees Celsius. Sorry. We need to solve for the XC at 70 degrees Fahrenheit. And then earlier, isn't that we were able to solve for the XC roughly at 70 degrees Fahrenheit? Was it? So the XL at temperature is 70 degrees Fahrenheit from the diagram. is roughly 0.26 or 27, something like that. So that's your XL. The problem is your XC. What is the XC? You know that it's heptahydrate. Since it's heptahydrate, we can already solve for the XC. Again, XC is, what was it earlier? 20, what was the magnesium? 20 molar mass of magnesium, 24.31. So 24.31 plus 32 plus 4 times 16 all over 24.31 plus 32 plus 4 times 16 plus heptahydrate, so 7 times 18. What is this? Again, please. 0.4884. So let's just write these. This one would be 0.4884. This one is roughly 0.26. Okay, so we can already solve. This is F times XF is 0.325 is equal to L times XL is 0.26 plus C times XC. By the way, your C is already given as 2000. So 2000 times 0.4884. This is your equation letter A. So again, equation 1 and A. Can you please solve for F and L? What is F, guys? The other one's just 2000. F plus L is 2000. F equals L plus 2000. What will this give you? F is 7027.69. L is 5027.69. All right. So in here you have the F and you have the L. What's being asked is the amount of heat per ton of crystal, right? Okay. So using this one as well, you know that the concentration that you have is at temperature of, you're given in here, temperature of 120 degrees Fahrenheit at 0.325 mass fraction of the feed. And then at 70 degrees, and then mass fraction of the magma would be roughly the feed and the shock. So from what table do you call this? Figure Q1B. So from figure Q1B, siya yung MgSO4. That's H diagram. So at 120 degrees Fahrenheit, and so 120 degrees Fahrenheit and XF of 0.325, and then at 70 degrees Fahrenheit and XM, which is roughly the same as our XF until before it crystallizes 0.325. What would be the HF and the HM? So in here, 120 is this line, and then 0.325 is here in the middle. Is it 0.35? Negative 20, negative 35. So here, It's approximately negative 35 BTU per pound, zero solution. And then at 70 degrees, it's this line at 325 is here. So it's roughly 75 or 78. So let's just say 78 or 70. Yeah. So here what you have is negative 78 BTU per pound. So why do I have to know this? Because take note, what's the formula? Isn't it that the formula that we have is here and this one as well? So basically, Q is the change in enthalpy. So what's that? Final minus initial. The final is negative 78 minus negative 35. You will get how much, guys? Negative 43 BTU per pound. However, you have the formation of how much is the formation of ilan ba yung feed natin? Di ba the feed is 7,027? So that means multiply this by 7,027.69 pounds for every ton of crystal. That's the feed. What will this be, guys? This is negative 302,191 BTU per ton of crystal. Or I can see that the heat is 302,191 BTU per ton of crystals. So this would be your final answer. All right.